Welcome to Security Operations, Topic 4.2.1. In this section, we will analyze common vulnerabilities and attacks and look at solutions to reduce the attack surface. Injection. This happens when untrusted input is sent to an interpreter, such as SQL or an operating system shell. For example, using 1 equals 1 in a SQL query allows attackers to bypass login. Mitigation includes parameterized queries and input validation. Cross-site scripting, or XSS. An attacker injects malicious JavaScript into a trusted website. For example, a script in a blog comment can run in the browser of every visitor. The fix is sanitizing input and encoding output. Unsafe memory utilization. This occurs when applications fail to manage memory safely. For example, a buffer overflow in C code can allow execution of malicious code. Use memory-safe languages and compiler protections to prevent this. Race condition. 2 processes access the same resource at the same time, creating unexpected results. For example, a banking app may process 2 withdrawal requests before updating the balance. Use synchronization and locking to avoid this. Cross-site request forgery, or CSRF. A login user is tricked into sending unauthorized requests. For example, a hidden link forces a transfer of funds. Solutions include anti-CSRF tokens and same-site cookies. Insecure configuration. This includes default passwords, unnecessary open ports, or weak settings. For example, an admin panel left open without authentication. The solution is hardening systems and applying secure configuration baselines. Embedded secrets. Developers may hard-code passwords or API keys inside source code. If leaked, attackers gain access to sensitive systems. Use a secret manager and never store secrets in code. Outdated or unpatched software. Old versions often have known vulnerabilities. For example, the Apache struts flaw that led to the Equifax breach. The fix is regular patching and vulnerability scanning. End-of-life software. When support ends, no more security updates are released. For example, Windows 7 after 2020. Migrate to supported versions to reduce risk. Poisoning. This refers to corrupting trusted data, such as DNS poisoning or machine learning model poisoning. For example, redirecting users to a fake site through DNS cache poisoning. Mitigation includes DenSec and data validation. Directory service misconfiguration. Weak LDAP or Active Directory settings may allow privilege escalation. For example, anonymous binds exposing all user accounts. Harden directory services and enable auditing. Overflows. This occurs when extra input exceeds memory limits. For example, too many characters in a field can overwrite memory and execute code. Bounds checking and memory protections reduce this risk. Deprecated functions. Using insecure or outdated functions creates weaknesses. For example, hashing password with MD5 or SHA-1. Use strong alternatives like BCYPT or Argon2. Vulnerable third parties. Suppliers, vendors, or open source libraries may introduce risks. For example, the SolarWinds supply chain attack. Mitigation includes vendor risk management and software bill of materials. Time of check to time of use, or TOC-TOU. This race condition occurs when a resource changes between verification and use. For example, a file is swapped with a malicious one after a permission check. Use atomic operations and secure coding practices. Deserialization. When untrusted serialized objects are loaded, attackers may inject malicious code. For example, insecure Java deserialization attacks. The solution is to avoid deserializing untrusted input. Weak ciphers. Old algorithms like DES or RC can be broken easily. Mitigation is using strong ciphers such as AES 256 and TLS 1.3. Confused deputy problem. This occurs when a program with higher privileges is tricked into misusing its authority. For example, a compiler writing to a restricted file. Use strict authentication and capability-based controls. Implants. These are malicious codes or backdoors placed for persistence. For example, firmware implants or rootkits. Mitigation includes secure boot, endpoint detection, and firmware integrity checks. This concludes the Vulnerabilities and Attacks section. Remember, knowing the weakness, the real-world example, and the mitigation strategy is a key to reducing the attack surface.